Good morning, my lovely kiddos. Today we are going to be talking about 3.2 parallel lines and transversals. This is going to work off what we did yesterday with the introduction of corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Okay, so our first blank here is the corresponding angles theorem. Remember that corresponding angles are the ones that are in corresponding places. So top right on the first intersection and top right on the second intersection. Okay? And this says that if two parallel lines are cut by a transversal. So yesterday it was just any two lines that were facing whatever direction. This today have to be parallel lines. And if those are cut by a transversal that goes in between both of them, then the corresponding angles are congruent. Okay, so let's draw a quick picture. So in this case, we have two parallel lines. And remember, to say that we have parallel lines, there has to be little arrows on them. And they are cut by a transversal, just a line that goes in between them. Then the corresponding angles, so top left and top left, those would be congruent. Okay? Remember, congruent equal the same. They have the same angle measure. Next, we have the alternate interior angles theorem. Remember that alternate interior angles are on the inside of the two lines and on opposite sides of the transversal. Again, if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Let's draw a photo. Again, we have two lines. We know that they're going to be parallel, so I'm going to draw the little arrows on them. We have a transversal. So we know that these are going to be on the inside of the two parallel lines and on opposite sides of the transversal. So this one and this one would be a good pair. Also this and this would be a good pair. Okay? Next, we have the alternate exterior angles theorem. And remember, alternate exterior is on the outside of the parallel lines and on opposite sides of the transversal. And again, this says that if we have two parallel lines cut by a transversal, then the alternate exterior angles are congruent. Okay, we'll draw a picture here as well. We have two parallel lines, and because we know that these are parallel, I'm going to draw these little arrows. We have a transversal. These are alternate exterior angles, so on the outside and on opposite sides of the transversal. So here and here would be a good pair, or here and here would be a good pair. Okay? And finally, we have the consecutive interior angles theorem. And again, that says if two parallel lines are cut by a transversal, then the consecutive interior angles are, and I know you want to guess congruent because that's what all the other ones said, but this one is supplementary. Remember that supplementary means that they add up to 180. Okay, so let's draw a picture. Okay, so we know that these are parallel lines, so I'm going to draw those little arrows. Okay, and consecutive interior are going to be on the inside of the parallel lines and on the same side as the transversal. So here and here would be a good example, or here and here would be a good example. Okay, so these are supplementary. So if you add these two angles together, you would get 180 degrees. Okay, and if you think about it further, we know that, let's say this circle down here, it is congruent with this angle right here, the top left. Okay, so this angle that's not marked plus this other angle, that would already give you 180 degrees because they form a straight line. So if you think about it a little further, it totally makes sense. Okay, so let's go ahead and look at this diagram and fill in these blanks. Classify the relationship between 117 degrees and angle 1. We have 117 degrees and angle 1. They are on opposite sides of two intersecting lines. So this would be vertical angles. And according to the theorem, these lines are, and we see these little arrows right here, so we know that these lines are parallel. And we know that vertical angles are always congruent. So if we wanted to find the measure of angle 1, since we know it's the same thing as 117 degrees, the measure of angle 1 is 117 degrees. Okay? Classify the relationship between 117 and angle 2. Well, they are both on the outside of these parallel lines, and one is on the right side of the transversal and one is on the left side, so they are on alternate sides. So I would say alternate exterior. And according to the theorems, because the lines are, again, parallel, if we look back up to our definitions, every single one specifies that these lines must be parallel. Okay? These angles are congruent because alternate exterior angles are congruent. So if 117 is congruent equal the same as angle 2, then the measure of angle 2 is also 117 degrees. Okay, let's go ahead and flip it over. Classify the relationship between 122 and angle 1. They are both on the inside of these parallel lines, and we know that they are parallel lines because of these two little arrows. Angle 1 and 122, they are on opposite sides of the transversal. One is on the left side, one is on the right side. So I would say that these are alternate interior. And again, according to the theorem, because the lines are parallel, because that is very important in this section, misspelled that. There we go. These angles are, alternate interior angles are congruent. So if 122 and angle 1 are congruent, equal the same, then the measure of angle 1 is also 122 degrees. Okay. 122 and angle 2, these are both on the interior of the parallel lines, but they are on the same side of the transversal, so this would be consecutive interior. And according to the theorem, these lines are parallel. Okay? And these angles, again, you always want to say congruent because that's what all the other ones are. But because they are on the same side of the transversal, and again, angle 2 and angle, this unmarked angle up here, they are corresponding. So that means this is the same as angle 2. So these two angles need to be supplementary to add to 180 to form a linear pair. So these are supplementary. So all we have to do here is take 180 and subtract that from the existing angle we already have, 122, and we are left with 58 degrees. That means that angle 2 must be 58 degrees. Okay, now we're going to start with some algebra stuff because why not? Okay, here it says let's classify the relationship between 128 degrees and 2x. Okay, these are both on the interior of these parallel lines, but they are on opposite sides of the transversal. One is on the left, one is on the right. So this would be alternate interior. And according to the theorem, because these lines they're parallel because of these two little arrows right here. And alternate interior angles are congruent. Congruent, equal, the same. Okay, so we are going to do our 3 steps, just like what we did with the angle addition postulate and the segment addition postulate. The first thing we're going to do is I'm just going to write everything down. We have, since we have no names here, I'm just going to go ahead and write the numbers. So we have 2 times x is equal, congruent, the same as 128 degrees. Okay, this is where we would usually name it, saying like, oh, angle 1 is equal to angle 2. And then here in substitute is where we would actually plug in the numbers. But again, since we don't have any naming tools to name these angles, I just wrote the same thing down twice. And then in order to solve, we work backwards through PEMDAS. There is no addition or subtraction here, so we move up to multiplication division. I see some multiplication here between our 2 and our x, our coefficient and our variable. So we are going to divide each side by our coefficient of 2. Multiply by 2, divide by 2, those are going to cancel, leaving us with just a positive 1x that we don't have to write the 1 to. And 128 divided by 2 is 64. So x is 64 in this case. Okay, this next one is a little trickier. We want to classify the relationship between 72 and 7x plus 24. They are both on the interior of the parallel lines, but they are both on the same side of the transversal, so that means that they are consecutive interior. Okay, and according to the theorem, because these lines are, again, parallel, that is so important with these theorems. And we have those arrows to prove it. These angles are, and I know everybody wants to say that consecutive angles are congruent because that's what the other 3 are, but you have to remember that consecutive angles are supplementary. Okay, again, we don't have any naming tools, so I'm just going to write this stuff down. Supplementary means that when we add them together, we get 180. So I'm going to add together our 7x plus 24 plus our second angle of 72, and they are going to be equal to 180 because they are supplementary. Okay, again, setup is usually when we would name things. Angle 1 plus angle 2 is equal to 180, but since we don't have any naming tools, I just wrote down the numbers, which you would usually do in substitution, so I am just going to write them down again. Okay, the first thing I'm going to do is combine these like terms. We have 2 constant terms on the left side of the equation, and if you add 24 and 72, you are going to get 96. So I'm going to bring down our 7x, combine our like terms into 96, and that is still equal to 180. Next, I'm just going to go backwards through PEMDAS, so I want to look for addition or subtraction, and I see some addition right here. So to get rid of that, we are going to have to subtract that 96 once from each side of the equal sign. Plus 96 minus 96, those are going to cancel. I'm going to bring down that 7x, bring down our equal sign, and 180 minus 96 is 84. Okay, I don't see any more addition or subtraction, so now we are going to move on to multiplication and division, and I see some multiplication going on between our 7 and our x, so to get rid of that multiplication, we are going to have to divide by our coefficient of 7, ones on each side of the equal sign. Multiply by 7, divide by 7, those are going to cancel, leaving us with a positive 1x. And then 84 divided by 7 is going to give us 12.